All right, so what I got today is on Revved Up Reflections. It's just an informal talk on. We'll start off with valve events and cam events. A long time ago, I needed some cams that weren't off the shelf cams, and asked around some people, and they led me to a longtime cam designer. I guess nowadays they'd call it a boutique because he would do pretty much whatever you wanted. I mean, he had his own stuff, but you could pretty much tell him what you want, what you're doing with the bike, drag racing, road racing, land speed, whatever, turbo, non-turbo, supercharger, whatever. And he would make a recommendation to you. Called this guy up, never talked to him before in my life, he'd been a long time cam designer, brilliant as far as cams go. His cam been doing it a long time. Cam's always made great power. Well known for his work, at least in the Harley world. And called him and I'm asking about cams, and he's like, "Well, what are your heads flowing? What are you using the bike for? All that." So talked to him, using it for road racing. And first off, he says, "Oh, I don't make cams for 91 and up Sportsters." Okay. And he goes, "But what I do, I make lobes. And you can grind your cam lobes off, precision ground, and fit my cam lobes on there, and you'll have to time them. You'll put them all on the bike there. So you grind them, you put his cam lobes on where you think they should be, and it's just enough fit to where you ain't got no pressure on them. It's just enough fit so you can time them. If you need to, you can mark it, pull them back off, and move them, half a degree or 1 degree or whatever you want." So he's going through the process of that. And we were on the phone for 2 hours talking. Well, he was talking, I was listening, because obviously knows a hell of a lot more than I do. I'd never seen any of his cams before. I mean, I could picture them. I'd seen pictures like the shovelhead cams, and truth is, they look like a rectangle almost. With the corners rounded off a little bit. So I'm listening to the guy, and he's like, "Well, my idea is I want to open them really quick, hold them open for a long time, and then slam them shut." And, I knew a little bit about valve bounce and float and toss. And I'd ask him a question about, well, doesn't that make if your opening ramp is so harsh, doesn't that toss the valve open and hold it open? He's like, "Well, I got a little bit of a clearance ramp in there, so it's not like it just slams it open, which can lead to toss, which is basically the valve calling it off the seat because the acceleration rate of the cam is so fast that it just throws the valve open." So he's going through the process because, like I said, I know a little bit about it. And I said, "What about the bounce, which is where it closes?" "Yeah, I got a clearance ramp in there, so it doesn't just slam the valve shut because nothing's going to last that long." Ended up buying the lobes and doing the work, buying the lobes, cam lobes. And we're still on the phone, and he's like, "Now you're going to have to keep valve springs in this thing because it's pretty harsh on valve springs the way his cam profiles are." I'm like, "Damn, I'm already spending a shitload of money on Harley valve springs." So he's like, "Do yourself a favor. Go to Comp Cams or Crane or somebody like that and just buy these car valve springs. You can buy a whole box of them, whole box of 16 valve springs for a hell of a lot less than you're buying 4 Harley valve springs for, which, the same company's making all the valve springs. They're just rename them. You know, these are for Harley, these are for Chevrolet, these are for Ford, these are for Dodge. You know, truth is, pretty much one company's making all those valve springs, and then they're selling them to whoever, and they're branding them to whoever they're making them. So he was right about that. So I got these not valve springs. I got these cam lobes in, and precision ground the cams. Or I didn't even use. I had a good set of Andrews cams. I used an old set of stock Harley cams. Ground those down, and I'm still running Andrews cams in my bike because didn't want to take it apart at that time till I got this thing. So I stuck these in a dummy motor on the bench to time them. Had just enough press fit that it wasn't a big deal to take them and take a lead hammer and smack them a little, mark them and smack them a little bit, put them back in the cam cover, stick your dial indicator in there. And I got a degree wheel on there so I could tell when the cam lobe's opening and closing. But went through that, took several days to get, actually took over a week to get it just right. Not a full week of me working on it 8 hours a day, just, here and there I'd be doing it, get frustrated, and whenever you get frustrated doing something, put it down, go do something else, and then come back to it. So I eventually got them timed up right, and, did like you said, TIG weld a bead around where you can get to on the cam, so I TIG welded a little bead around there once I had them set where I wanted them. And that was the ticket. Those things were rippers compared to the Andrews. And the Andrews cams I was using were pretty stout. I want to say I was using N9s in there, which were, I don't remember the duration and all that, long time ago. But lift was over 600 lift. I want to say 630 maybe. So it was opening valves pretty damn good. Now, his cams, they were about the same lift. They're over 600, and it might have been like 650 lift. So a lot of lift. And had no clearance problems because he used smaller base circles on the cams. So I had no case clearance problems because I already clearanced those for the Andrews. But valve spring wise, yeah, I did have to keep valve springs in it pretty much. And bought a set of comp cams valve springs for, I want to say, small block Chevy, which, free length was right, ID was right, OD of the springs was right for use with my collars because I was using titanium collars with the super lock keepers on there. I want to say they were super 10s, maybe 10-degree keepers for a little more stability. And this is way before conical valve springs. No, actually, than conical valve springs. I went to a seminar in 96, 97, 98. Actually, I went to them for like 3 years in a row, or two or 3 years in a row. And the first year there, it was probably 97, like January 97, maybe, I want to say, January, February 97. Went out to Colorado Springs because they had these conferences, AETC conference put on by Superflow in Colorado Springs. And this was the first year that they'd come out with them conical springs. 97 probably. Beehive springs, whatever you want to call it. Beehive, yeah. And neat, man, that they did a film on it that's, I want to say, can't remember the guy's name. It's Joe Lunati or John Lunati. Did a film that, I mean, the way he was explaining it, they were in the dyno room, and the guy in there had a video camera. When those things first came out, everybody was buying these video cams. Big thing compared to today. And he's, the guy's in the dyno room filming this thing, and he asked him, "Can you speed that film down, like really slow, once we process it?" He's like, yeah, I think I can. So they had this, I want to say, I don't remember, I want to say it was a NASCAR motor that they were testing. And they're filming it, at what the valves are doing at 5,000, what they're doing at 6,000, all the way up to 10,000 RPM. And it was pretty damn cool. You think that everybody thinks valve springs are doing this nice progressive movement up and down, but and they're just straight up and down, just moving like that. So he shows this film, and 5,000 RPM, they look normal. You could see a little bit of singing in the valve spring there, just a little bit. 6,000, you could see a little bit more. 7,000, you could really see the valve spring starting to do this, dancing all over the place. Same 8,000 more, 9,000. Unbelievable. It looks like the valve spring was dancing. I mean, it was all over the place in there. 10,000 was even worse. Then he was talking about he hadn't filmed any with the Beehive valve springs yet. He was talking about the way his engineers explained it to him. You're taking all this harmonics out of the straight, dual progressive wound springs. You're taking all that harmonics out of there, or you're not taking them. You're shifting them to a point to where they don't matter anymore because your valve springs aren't going to be moving like that. Standing around talking. I'm just keeping my mouth shut because I know very little about what they're talking about. I mean, I know enough to know what they're talking about, but at that point, I'm just a young guy, a hell of a lot younger than I am now. So I'm just keeping my mouth shut because these are the pros, man. Lunati, Bill Grumpy Jenkins, Joe Mondello. They're standing around talking, and they had he was giving a presentation on this LS7 engine, I guess, which was new at that time. I think it was LS7. The one with the exhaust ports that look like urinals. I think that's an LS7. And that's what Joe Mondello said. He's like, or one of them, maybe it was Jenkins, goes, these things look like urinals. They work. They had Beehive valve springs in this thing, and Mondello's like, yeah, Oldsmobile tried those back in the 50s, and they didn't work. Lunati's like, yeah, but that was 40-something years ago. They didn't have the same industrial processes for making spring wire, the same metallurgy that we have now. And they work now. They don't break, because evidently back when Oldsmobile tried, they were breaking the hell out of them valve springs back then. Anyway, I'm getting off topic here. I'm just, this is just an informal talk about stuff that I've only scratched the surface on because I'm no expert on. I know a little bit, probably enough to get myself in trouble. And I've broken valve springs. I know how to set valve springs up. I've broken them. I've used titanium valves. I've manufactured valve seats. I bought titanium valve blanks and cut them down, and then welded the tips up and reground them, so you have a nice hard tip on there. And this is all stuff, I didn't figure this stuff out by myself. You call an expert that does them, and I had called somebody and was talking about latch caps for the titanium valves. And I want to say I called somebody at Camshafts maybe. And I don't remember who I talked to, but guy's just like, why don't you just stellite weld the tips of the valves? And I was like, I didn't know you could do that. He's like, got a TIG welder? Yep. Got a TIG welder, got a welding bubble, I can mix my own gas for welding. So he's like, hold on for a second. So he puts me on the phone with some other guy, and he's going through the process with me. He's like, man, go down here, call your welding supplier, and see if he can get you these stellite rods. You don't need a whole bunch of them, because they are kind of expensive. Okay. So he says, this is the gas mix you want to use. You need to make sure that the valve is extremely clean. But since you're doing it in a bubble, you're going to purge all the oxygen out of the bubble and weld in there. Because when you weld titanium, as soon as you break the arc, break the bead, it's going to oxidize almost immediately. So you really need to flood it. But in the bubble, you don't need to flood it because the whole thing's flooded. So I did that and put them in the valve grinder and ground the tips down to where I needed them. So I already cut the keeper groove, because you get a blank, and the blanks are, I want to say, like this long. And the heads are, whatever size you get the heads in, and cut the heads down in the lathe, cut the length down, cut the keeper groove in there, and got the length about where I wanted it, because you're not adding a 1/4 inch of stellite to the top of it, just enough to keep it. So I measured the overall length of the valve, cut it to where I needed it, then welded the tip, and I knew what valve length I wanted with the stellite, so I ground it down and put a mark on there, so I knew exactly where the stellite was, how much stellite I put on there. I measured the valve, no stellite, then I measured it after I did the stellite, then ground it down a little bit, remeasured it, so I had this length that I knew that I wanted. And they worked out really good with copper beryllium seats, which are all the rage at that time. I made the seats, controlled atmosphere, because that stuff's really toxic, like worse than asbestos. If you get berylliosis from cutting, grinding, whatever on the copper, not the copper, the beryllium is what's toxic. So whenever you work with the stuff, supplied air respirator in an enclosed room with suction, exhaust vent out through filter and all that crap. So nobody in the shop gets this beryllium. They're not breathing this stuff, so you're not killing anybody. Like I said, it sounds really high tech, but truth is, I didn't know what the hell I was doing. Truthfully, really, I had an inkling of an idea, and it just so happened that it worked. By lightening up using lighter valves, the titanium valves with those cams, I could drop my valve spring pressure a little bit anyway. I didn't drop it a whole lot. Always worried about stuff like that because I tended to over-rev stuff, which, for sports with cranks doing this, anything over 7,400 anyway. But I did use a semi-pressed together, bolt together, pressed together crank made by S&S, which was actually a short stroke crank that I ordered. I had this idea for an engine that was a 1347 that was, or 1348, whatever it was. It was under they had a limit for 1350 for this class of racing. So I ended up using 3 13/16 barrels that I'd shortened a little bit. And, I had to order pistons for it. And I had to make my own push rods, because, shorter push rods, all that stuff. The S&S crank the left side was press in. So you press it together and then weld it around the outside of the crank pen. And then the right side was on a taper. But with the S&S pens like that, you could torque the flywheels a hell of a lot tighter than you could stock Harley wheels. And when I ordered them, I had requested them not balanced, because I don't like the S&S balance factor. They like to use a different balance factor than I used. So I did mine at 65%, I believe, is what I used. It came up with, and I came up with that by reading an engineering book from the 20s or 30s about it. So, of course, some German scientists came up with this idea. It might have been British, I don't remember. But somebody came up with this, basically you consider the RPM range that you're running at and RPM range that you're running at, your stroke, your bore, all that stuff, and how much the rods weigh. Of course, you need to know the reciprocating and rotating weights with the crank pin weight, the bearing weight, all of that. And I came up with 65%, and that thing worked good. I could actually pull. Well, the most I ever revved it was like 8,200 before I noticed any ill effects, and promptly decided that I'm not going over 8,000 on that thing because you could, I don't know about anybody else, but I could feel the crank starting to do this. And what I would do from experience, I learned that, if you're setting up a race motor with the Temkin bearings and the pinion bearings, you already know that the crank's flexing. So you set up your sprocket bearings loose. Instead of a tight 2000s fit on the bearings, which Temkin actually recommends, and Harley recommends slightly more clearance than Temkin does. I set them up looser because I had locked up a set of sprocket bearings at one time at Daytona because, following the factory recommended procedure that I was taught to follow, set them up looser and correspondingly set up the pinion bearings looser. So if it does flex, it's not going to lock up the bearings. And a friend of mine who builds XR750 motors suggested that I convert over to these basically spherical bearings. So, because according to him, the crank's flexing. So, even the way you got the bearings set up in there, they can still lock up. So if you machine the cases for these spherical bearings, which basically are going to work, and they let the motor do whatever it's going to do. They allow for any misalignment in there. What I did at one time over on the primary side here, there's your crank comes out and you got a gear on there. There's no support like on the right side. You've got your pinion bearing support on the out on the end of the crank and the cam cover. On this side, primary side, you have no support. So I'd taken a old primary, and made a bearing plate and machined it into the primary cover here, welded it in place, and then finished machined it, and used a bearing in the outside of the primary cover with a that fit right on the end of the crankshaft there. And I used a spherical bearing out here, so if it did, it had some support on the outside here, so it's kind of holding the crank. And if I'd done a little bit more precision on that, it probably would have worked better. But ended up cracking the primary out here, probably due to ill engineering on my part. Or not probably, it was ill engineering on my part because it was just too much stress, because primary is pretty thin, truthfully. And it's got ribs cut in here. And when I had machined it and welded it, I had to cut these ribs out. And it just something that didn't work. Could have swore it was going to work. It seemed like a genius idea, but sometimes when you're doing hot rod stuff, sometimes things just don't work. And oftentimes there's a reason it doesn't work, and it's usually some you didn't have your clearances right, or you didn't take into account something else. So whatever. But there's a lot to this hot rod and stuff, and you can't just say that something doesn't work. I've run into guys like that before. That shit don't work. Engineering term that I read about that made sense to me at the time, that you can't just automatically assume that something doesn't work without trying every single variable, taking into consideration every single little thing. Clearances, metallurgy, setup. What affects what? Well, you change the cam timing, and it didn't work. Okay. So I hope that made sense to you. Me just rambling. Instead of revved up reflections, I would just call this some old guy rambling on about crap. Anyway, anybody have a great week. Appreciate you guys watching. Appreciate subscribers, comments, all that stuff. Really appreciate it.